This is 10.3, matrices and a system of linear equations. We just got done doing two lessons on a system of linear equations. Let's talk about matrices. We kind of touched on this last semester, but matrices is basically a simple way to focus on just the numeric values of the system. So for instance, this might literally, I have an example here: male, female, immature, juvenile, adult. And this is talking about a population of endangered whales. But anyway, this literally could be like 12x plus 52y equals 18, and then 15x plus 42y equals 11. So that's literally your system of equations. You're just taking the numeric values and keeping them in real life, like something like Amazon or Walmart or something like that. When they're doing a massive order of shoes or clothing items or whatever it is, they basically on their computer, it's built in to do like a matrix, and they just type in the numeric values of whatever it is. Or when a coach orders T-shirt sizes, small, medium, large, extra large, and for males or females, they basically make a chart system, and they make basically they're making a matrix and a little column sheet on Excel. Microsoft Excel is basically a matrix. It's just a collection of data in rows and columns. So the very first thing is you have a linear system like this, and this is called the augmented matrix. Basically, you take all the numbers from that linear system and you write it in as just the numeric values of it, and that's called the augmented matrix. So let's first do that first. You always do that. And then from there, we're going to go make sure you understand what a definition of a matrix is. So again, it's a matrix that has a different size of it. Again, think of Microsoft Excel that it might have a 4x5 column or a 20x13 column or whatever it is, and it's based off of M times N matrix. So the number of rows and then columns. So for instance, I have some examples down here. So here's an example. I got two rows. So here's row 1, here's row 2, row 1, row 2, and here's column. It actually has 3 columns: column 1, column 2, column 3. So this is a 2x3. Okay, a 2x3 matrix. That's the size of it. This next example that I have here, this matrix here is 1 row, but it has 4 columns. So that's a 1x4 matrix. So you do need to know the size of the matrix. Again, it goes row first and then column. All right, so again, another example. So I have a linear system. We write it in augmented matrix. Again, we're just focusing on the numeric values of each one of those. So 3, -2, 1, 5. 3, -2, 1, 5. And notice you have a 1, 2, 3, 3 rows, and then you have 1, 2, 3, 4 columns. So this is a 3x4 matrix. Okay, 3 this way, 4 that way. So 3x4 matrix. All right, so again, the same thing. I want to make sure you understand, write the augmented matrix first, following a system. So here's your system right here. You might want to think of it as this. Notice they leave spaces for y's, they leave spaces for your x's that are blank, and they basically write all the x's in a column, all the y's in a column, all the z's, and then all the numbers are all in a separate column. Then from there, then you can write the augmented matrix. Okay, so make sure everything lines up. X's are in the first column. This is my y's, this is my z's, and this is my number in those columns. So that's how you write an augmented matrix. All right, so let's go ahead and let's use elementary row operations to solve a linear system. And let me emphasize this. There are multiple ways to solve this. So the way that I'm doing it, I don't want you to think is the only way to do it. It's just what I might see as an easy calculation. You might see something else as an easier calculation, and you can do it that way as well. So if I had a problem like this, it's up to you. You might want to look at this problem and you might decide to cancel out the x's, or you might decide to cancel out the y's. It is totally up to you which one you want to do. So, I look at this and I notice this is, by the way, this is a 3x4 matrix. So very first thing I do, if I'm doing this, matrix form, I want to write the augmented matrix. So this is 1, negative 1, 3, 4, and then 1, 2, negative 2, 10, and then 3, negative 1, 5, 14. And this is the augmented matrix. Again, I'm just writing the numeric values. And just so you know, some textbooks or websites, what they do is they'll draw a line here, and just to let you know that that keeps it straight. Like this is all my x's, this is all my y's, this is all my z's, and this is like basically my equal sign, and then my number. Again, you don't have to draw that line, but just to let you keep it straight, it's there. Okay, that's the fourth column. All right, so what we're going to do is decide on what we want to cancel out, and again, depending on what you want to do, I may want to cancel out. I see the x's can cancel out very easily on this, or the y's can cancel out very easily. There's multiple options here that you can do. I think the x's or y's would be easier to do than the z's. So I'm going to concentrate on the x's in this particular problem. So I'm going to concentrate on the row 1 and row 2. And remember the notation. So if I take row 1 and I subtract row 2, so I'm literally taking row 1 and row 2, I'm going to subtract them. And I'm not going to touch row 1. I'm just going to actually leave row 1 alone. I'm going to take row 1 minus row 2, and I'm going to subtract those, and that's going to give me 0, and minus 3, and 5, and negative 6. So again, I took row 1 minus row 2. And that's that one right there. And then what I'm going to do is I'm going to try to cancel out this same row again. And I canceled out my x's, so I want to cancel out my x's again. So I'm going to take, let's take row 1, but I'm taking 3 times, negative 3 times row 1, and I'm going to add that to row 3. Okay, so negative 3 times row 1, so I'm taking 3 times each of these values, row 1, and I'm going to add it to this. So that way it's negative 3 times 1 is negative 3, and negative 3 plus 3 is going to give me 0. That's going to give me 0 there. So I'm going to end up doing that. And so I carried that out. There's a couple things we could do. I do notice this new column that I came up with. I can literally divide this whole thing by 2 if I wanted to. It would make it easier if I divided that all by 2, and that would. So I'm going to go ahead and do that. I'm just going to multiply everything by 2. Okay, so I went ahead and divided everything by 2 right there, what I have highlighted. So the only thing changed was this row 3. So all I did was take half of row 3. That's all I did, took half of it. I divided everything by 2. Now, again, what I'm trying to do, keep in mind, I'm trying to get it in triangle format. So it would be very nice if I got rid of that. So that way it would, then I could literally see z equals blank. Okay, I can literally see that. So that's what I'm going to try to concentrate on. And so I'm going to multiply. Row 2 by or row 3 by 3, and then add it to row 2. All right, so I took 3 times row 3 I took 3 times this row, and then I added it to row 2, and I recorded everything right here. So that's 0, 0, negative 1 equals negative 3. So from here, now I can see that right there, that z equals 3. So once I have z equals 3, then I can back substitute it in. So notice this one right here. So really what I have is if I write that back into like a linear equation, I have 1x minus 1y or minus y plus 3z equals 4. I have negative 3y plus 5z equals negative 6, and now I have z equals 3. And then I'm just going to back substitute it in. I can substitute z equals 3 into here, solve for y, and then once I solve for y, I can plug in those right there to find. All right, so and then I finally get my answers 2, 7, 3. So this is your x, that's your y, that's your z, and you can always check it. Remember, you can always plug in 2 for your x, your 7 for your y, and 3 for your z, and it should equal 4. And then plug them into the second equation, it should equal 10. Plug them into the third equation, it should equal 14. And there you can check your answers that way. All right, so let's look at Gaussian elimination, or some people pronounce it Gaussian, but Gaussian elimination. And so what we're going to do is take this same idea, and we're going to use the same principle. The only difference with this, what we did on the other one, a row echelon form, we just used row operations, and we literally solve for whatever variable we want. Now, Gaussian elimination, what it does is we're going to try to get this. We want a 1 here, and then zeros underneath, a 1 here, 0 underneath, and a 1 here. And then once we get down to here, this is like my row here. Once I get down to here, that's like in triangle form. So then, whatever number's over here, like that, if that's a 5 or whatever. So then once I get it to look like this, then I know what that is, z equals 5, then I can back substitute in. So what I'm trying to get is this little triangle of zeros here. So in this case, notice that it's a 3 by 4 matrix. And so first step is write the augmented matrix. So we're going to first do that. All right, so we wrote it in the augmented matrix. And then we're going to use those elementary row operations. But again, what we're trying to find, our very first step is we want this to be a 1. And then we want zeros underneath of them. Okay, so that's really what we're trying to do. So the very first thing is to get that to be a 1, we're going to divide everything by 2. So we're literally going to take, the very first step is we're going to take half of row 1. Our next step, and again, I've already said it, we're trying to get these two spaces to be zeros. And there's multiple ways to do this. So the way that I'm doing it, don't think that that has to be the hard and fast way to do it. But ultimately, to do in Gaussian elimination, we want 1. Just keep that in mind. We want 1 and then zeros underneath. And then we want a 1 here and a 0 underneath. And that pattern continues. No matter how big the matrix is, that's really what you're trying to do, is get it all the way down to triangle form. And the very last row, you'll have z equals blank, some number. That's what we're trying to do. So to be able to do this, I want to get these two guys to be zeros. All right, so I went and wrote the next step, but keep in mind, I keep saying this, there's multiple ways to do this. But to do in Gaussian elimination, you really want to try to get this format, okay? This format right here, where you want 1 on top in the first row and then zeros underneath. So, you got to think how you want to get this to be a 0 and this to be a 0. And so I did R2 minus R1, and then also I did R3 subtract 3 times R1. So notice I got 1 and then 0, 0. And so next step is to get a 1 right here. And so basically I'm going to divide this whole column, this whole row 2, I'm going to divide that by 4, because I can see a 4 coming with all those. So I'm just going to divide that by 4, and that makes that one easy. And then again, I'm trying to get this guy to be a 0. Okay, if that's a 1, if I want to get that guy to be a 1, I want this guy to be a 0. So I'm going to do that in the next step. All right, so I did exactly what I did. I got 0 underneath both of those. I got 0 there. I got a 1 there. So because I did all of that, you could see that this is now, you could literally see that z, it's a -6, by the way. So that you can see that 6z, or 6z equals 24, so you know that z equals 4. Okay, so once you have z equals 4, then you could start back substituting in to find your y, and then once you know that, then you can back substitute it in. So you're going to end up getting 374. So again, this is your x, that's your y, that's your z, and I did it using the Gaussian elimination method. So one thing that you can do is obviously double check this. You can always use, back on the TI-84, you can also check matrices using the graphing calculator. You can plug in the matrix, and it actually has a command on there, a math command, to put it in the Gaussian elimination, get it all the way down to row echelon form. So you can always check this answer in the calculator as well. So that's how you start adding. the matrices, and put it in an augmented matrix, and then solving for the variables.